Good morning. Thanks for being here on our last day of reInvent. I'm sure everybody had a great time last night, so I appreciate you making it to our session today. We have a great story to tell you today about Verizon and how they're using continuous security to validate their security infrastructure and how they're using Lambda for self-healing and auto-remediation. My name is Matthew Dwyer. I'm a senior practice manager with Professional Services based in New York. I'm excited to be on stage today with Chris Durand. Chris is the Director of Cloud Security Integration Services at Verizon, as well as Chuck Dudley. Chuck is the Vice President of Services at Stelligent, and Stelligent is one of our AWS Premier Consulting partners. So today we're going to talk to you about Verizon's journey to AWS and their strategic plan for scaling security. We'll talk about the concept of and practical implementation of continuous security and how it fits into an overall DevOps strategy. We'll do a deep dive into some CloudFormation templates and automating the certification of CloudFormation stacks. And I'm going to talk to you today a little bit about AWS Professional Services, our methodology and our approach to helping customers with their AWS security architecture. So Professional Services started back in about 2013. We spent a few years working with our customers, helping them with their cloud adoption journey. And at that point, the team got together and conducted a working backwards session to try to really understand where our customers were going with their journey to AWS and how we could be prescriptive in helping them along the way. So the team came up with the Cloud Adoption Framework, or the CAF. It's a framework that breaks down the planning process into focus areas that we call perspectives. There are 6 perspectives, one of them being the security perspective. And if you'd like more information on the CAF, you can go to the AWS public website. Under Professional Services, there are white papers that walk you through the CAF, as well as white papers on each of the 6 perspectives. But the goal of the security perspective is to really help you define a security strategy and also provide guidance on implementing a security program. And so there are 4 sets of controls that we use as guides when actually building the security strategy. Directive controls, which establish governance, risk, and compliance models. Preventative controls, which protect workloads and mitigate against threats and vulnerabilities. Detective controls, which provide visibility and transparency for the operation of your workloads in AWS. And responsive controls, which is remediation and incident response, should there be any issues. So once the strategy is defined, you can use the Cloud Adoption Framework security epics to implement the security program. The goal of these epics is to build a foundation of a security program that can be iterated on through continuous security. Organizing the implementation around these security epics ultimately helps you achieve your goals faster and more efficiently. Each epic consists of user groups or use cases that are worked on during sprints. So during the first sprint planning, we'd help, or you yourself are defining your MVP, your minimum viable product, you're defining your baseline, and then each incremental sprint, you're working towards that baseline, layering in more complex requirements. We separate the security epics into 2 categories. There's the core 5. These are the epics that should be implemented early on in your journey to AWS. These are foundational to any AWS security program or security platform, and they're core to all security components on AWS. We also have what we call the augmented 5. So these epics represent the themes that will drive continuous security through availability, automation, and auditing. And the goal here is to incrementally add these epics to your program once you've built out the core 5 and you have a foundation from which to work on. Now, Verizon, when they implemented this security program, they implemented all 5 core epics, and at the time that they did this, there were only 3 augmented epics. And Chris is going to talk to you about that in more detail. To accelerate the delivery of, once you have your security strategy, you have your epics sort of planned out, we recommend organizing around each epic and building dedicated teams that will focus in each of those areas of depth. This is a concept, I'm sure you've heard this, whether it be this week or in other sessions, about a 2-pizza team. And this is something that Jeff Bezos implemented 10, 12 years ago. He had a concern that Amazon was going to become too big and too bureaucratic, and he wanted to remain agile and nimble and be able to innovate at scale. So he said, listen, I don't want any team so big that they can't be fed with 2 pizzas. And that's a model that we all follow today, whether it's AWS, Prime, retail, any of the businesses within Amazon. And the goal with a 2-pizza team is to be small, autonomous, but enabling speed and innovation. So when you're building out your security strategy and security epics, we recommend organizing around 2 pizza teams with an area of depth in each epic. And then to increase velocity and accelerate, what Verizon did is they created 2 pizza teams for each security epic that they were implementing. And what they did is they inserted an AWS professional service consultant on each team to provide some area of depth and staff the rest of the team with Verizon consultants. We did this with these 5 core epics, and then there was the 3 augmented epics that we're all working on simultaneously. And Chuck Dudley and Stelligent played a key role in working on the DevSecOps, which he will go into in more detail later today. But ultimately, the goal of the security program is to enable your organization to build the skills necessary to deliver continuous security and help foster a culture of security ownership across the whole organization. So at this time, I'm going to hand it over to Chris Durant. Chris is going to talk to you about Verizon's specific journey to AWS and how Verizon implemented their AWS continuous security program. Chris?
Welcome. So today I'm going to give you a little bit of context around Verizon and how Verizon addressed security within the public cloud, specifically with AWS. I'm going to try and set some context for you. I'm going to share with you some scenarios and some examples of some of the things that we've done. And ultimately, I'm going to tee it up for Chuck to take over and get deeper into one of our areas of security, which really focuses on preventative controls, as Matt referenced. And that's in the area of CI/CD security, essentially in the area of preventing security violations from occurring in the first place. Before we dive into the security aspects, just a little bit about Verizon. So Verizon is a very large company. When you think about Verizon, you think about security in the cloud, you're going to think scale. Verizon's huge. Ranked number 14th in the Fortune 500, Verizon has an employee base of about the size of the population of Providence, Rhode Island. It's a very, very large company. Our footprint in AWS is very large to correspond with the size of that employee base, and we're going to get into that in a few slides. Fundamentals. As we approach security at Verizon, we came up with 4 fundamentals that really drove the program. First, migrate all. We were committed to being able to migrate every application that we have at Verizon. One of our core beliefs is that security should not prohibit the adoption of the cloud for any application. As a matter of fact, security should enable cloud adoption, and that's one of our objectives here. I will say that the cloud itself has become so mature that the options for configurations and the ability to secure applications, in my opinion, make it more secure than your on-prem. And it has positioned Verizon to take migrate all applications into the cloud approach. Full automation. That's the path to the cloud at Verizon. You cannot operate security or application deployments at scale manually. Everything is automated. And security is automated as well. Actually, security is code, as you'll see when we get into some of the examples. Enabler. Security is an enabler at Verizon. What that means is we build tools to help the development and engineering organizations adopt to the cloud. Oftentimes, security is perceived as in a negative fashion, as a disabler. But at Verizon, we build automation and automation tools to help the engineering teams adopt quicker, faster, and more seamlessly. And we'll talk about some of those tools. And last but not least, monitoring is not enough. Monitoring in the cloud is a cornerstone. You have to have it. It has to be robust. It has to be continuous. But you cannot just rely on monitoring. Think of scale. Think of how things change in the cloud. You don't want to be chasing after violations from a security perspective. It becomes whack-a-mole, especially as you start scaling and you get more and more accounts and hundreds of thousands of VMs. You don't want to start just chasing after violations of security. You need to think about preventing. And that's the theme of this entire presentation. Our journey, quickly, started in December of 2015. We started by moving about 500 applications into the cloud. All of them were considered non-prod. They were our test environments on-prem. We deployed them into an account structure that many of you may be familiar with, essentially a master account with line of business accounts for the applications to run in, and then some horizontals or shared services accounts that would serve up some infrastructure supporting tools that every application would need to consume. We also were very conservative about the data footprint in the cloud at that period of time. There was no live data. It was just test data. The approach, as Matt alluded to, we took an epic approach. Those are the epics to the right. We formalized the team, and each team had an epic manager that would run the various sprints and basically manage the priorities via the stories of each one of those epics, with the ultimate goal of building a security architecture and infrastructure that would run seamlessly in the cloud and ensure that all our applications were deployed in a manner that provided the level of security that we have to deliver to our customers and our shareholders. It was agile-based. There were key partnerships. Matt referenced one of them, and that was Amazon Professional Services. They participated in each one of these epics, and they were really invaluable because they provided us with best practices. In some areas, we did not know what the best practices are, but Amazon certainly does because they work with all of you, all their customers, and they know what best practices are, so they can definitely influence how you build your security program. We looked to leverage existing tools wherever possible. We didn't want to have to recreate everything, and we were able to use a lot of existing tooling. But there were gaps, and during those epics, we identified the gaps, and then we either had to build or buy something to remediate where we had risk from a gap perspective, which is exactly what we did. Log everything? We did. We logged everything. But then you got to put automation in place to make sure it stays logging. Full automation, spoke about that, and build CI/CD security. That's the focus of this presentation. And Chuck, I'm not going to steal his thunder because he's going to get into a lot more detail on that topic. Just a little bit about requirements. The very first one, onboarding, documentation, guidelines, policies, documentation that's incredibly voluminous. Keeping it current was a big challenge. And then oftentimes just finding it's a challenge. There's so much of it, and I'm sure a lot of you folks deal with the same challenge there. We took a risk-based approach at Verizon. Not every violation of security is of the same weight and risk. Certainly you want to focus your attention on the highest risk areas first, and then work into the medium and lower risk areas subsequently. Prevent compliance issues, that's the goal. We don't want to have to chase them down. We don't want to rely on just monitoring. We want to stop them. And stopping production issues from ever occurring is what we're talking about with our DevSecOps pipeline. But there's also auto-remediation capability to stop issues from happening. There's no reason why you can't turn most of your monitoring into auto-remediation. It's just the next logical step. Team of automation engineers. So building the security team. Security is code at Verizon. So the team to build security and build all that code is our engineering team. All the security practitioners at Verizon are DevOps engineers. They're Python coders, they're Ruby coders, and everything we do is based on code. So the whole security team is writing code. That's what we do. This slide is some examples of some of the solutions that we've been able to provide at Verizon in our cloud program. The very first one is a good example of an enabler. So hundreds of thousands of application developers building their infrastructure in the cloud. They all need IAM roles for instances and services. They build their own. We don't have to do this manually or through a provisioning team. They build their own roles, and we generate in an automated fashion keys to go with them, KMS keys, and we integrate the two together, thereby achieving some blast radius controls. We do static CloudFormation analysis and deploy the infrastructure and then do dynamic analysis as well. That's the DevSecOps pipeline that Chuck's going to talk about. We'll get into a lot more detail in a few slides on that. Auto-remediation. I have a few examples of auto-remediation here. As I mentioned, when you monitor things and you see violations, why not fix them? Security groups. If somebody creates a security group that's a violation to a policy, just remove it. And that's exactly what we do. Encryption. Policies are clear. Everything needs to be encrypted at rest. So if you create an RDS database and it's not encrypted, even in a lower environment, it doesn't last very long. It just gets deleted. In some cases, we actually remediate it. S3 encryption. If you create a bucket, we'll attempt to fix it if we can determine whose it is and what application it is, and if you have the appropriate keys in that region and in that account, we'll encrypt it for you. If not, it just goes away. Then when it goes away, we send emails and we put links to the documentation that they probably can't find to begin with to show them how to be compliant when they subsequently try and do this again. Self-remediation tools, that's another enabler sometimes, especially as people are introduced to the cloud in the lower environments, they struggle with some of these encryption techniques and requirements. So we provide tools for them to just execute through Jenkins, put in a bucket name, put in an application ID, and it just goes out and it reads all the objects, encrypts them, writes it back, and then puts a bucket policy on the bucket and makes sure that all subsequent writes are all going to be encrypted. And then there is a ton of monitoring, as you can imagine. So we monitor all of our logging, making sure that it's up, it's running, it's going to the right buckets as we create and deploy new accounts. Make sure it's all running the way we want it to be, so we don't have to manually look at it. It's just all being done in an automated fashion. Bucket policies, I threw that in there only because it's so vogue and everybody is aware of S3, and I'm sure you're all monitoring S3, and we do too. We monitor it a lot. Everything from bucket policies to ACLs to VPC, endpoint policies, you name it, we're looking at it. And in a lot of cases, we're remediating it at the same time we're looking at it. And then a ton of monitoring in IAM. Looking at everything from using Policy Simulator to make sure there's nothing overly pervasive or permissive, and as well as looking at trust and just a ton of opportunity to execute and deploy automation in the IAM space. Some of our challenges, scale. Scale is a challenge because we're so large. And the only way to meet that challenge is with automation, code. Put it together, code it, and put together a structure that executes in every account almost at a consistent and constant manner. Governance, another challenge. Governance is pretty straightforward. You set policies, you set guidelines, but enforcing and making sure people comply with them, that's the challenge. Again, scale comes into play. Diversity of applications. Verizon's a very big company, very diverse, tons of applications that struggle to comply. I don't know how many times I've had conversations with application developers. We can't rehydrate every 30 days, Chris. And fortunately, then you're not ready. You got to go back. You got to re-engineer. Culture, similar story. People still bringing pets into the cloud, and they got to leave their pets at home because they're not going to run in the cloud. You got to change that mentality. And again, a lot of this stuff in automation is the same thing. It's a maturity curve. Some groups are more mature, other groups aren't. And you work with these teams, and we're committed to working with all our technology and engineering divisions to get them to the cloud, because we're cloud advocates. We want people in the cloud. Partnerships, I mentioned partnerships. AWS, obviously, Matt was here just talking about how he helped us in terms of building, using the Epic approach. And now I'm going to turn it over to Chuck. He's going to come here and he's going to talk about our CI/CD pipeline specifically and some of the preventative controls we do around CloudFormation templates before we deploy into production.
All right. Thank you, Chris. Thanks, everyone, for showing up this morning. Appreciate it. I'm going to go pretty quick. I have a lot of material to cover. So we're going to start by just laying a quick foundation, DevOps and its applicability to security. The old model of delivering change through software was obviously a departmentally organized approach where you had silos that passed work from one department to another. This is an anti-pattern, a bad practice, simply because of two things. One is the queue time that happens when you transfer work from one department to another, and the other is loss of context when you move from when you transfer work without working closely with the people that have done the previous work or the people who are being handed off to. So, what we really want to do is bring together all of the resources necessary in order to be able to deliver change without blocking, without waiting, queuing, and without a lot of loss of context. When we talk about DevOps, one misnomer that we see quite often is people just think DevOps, it's development and operations, and that is just not true. It's actually everything from development through operations. And this is one of the key things that Chris was talking about that we were trying to achieve in this project, is actually to bring security into the process of migrating these applications, of delivering change through software. So in order to work effectively, we're going to have to bring together all these resources and have them operate as a tight-knit group and to not be able to not have to pass off work from one department to another, to not suffer queue time, to not suffer loss of context. one of the key approaches that you use in DevOps for delivering change is a practice called continuous delivery. The old method of release process of delivering change was typically to accumulate a lot of different code commits, changes, leading up to an epic event of a QA testing and a software release, usually resulting in people coming into work in the middle of the night, all hands on deck, running through a QA process, deploying, finding problems, rolling back, so on and so forth. The reason this process really doesn't work well is, one, if you're accumulating changes over a period of weeks or months, the person that's written that code is losing context as they go on and do other things. If there's a problem with code when you do your testing that was written 2 weeks ago, 2 months ago, it's usually much more difficult to figure out just what the problem is. But maybe even more importantly than that, subsequent changes may have relied on the way that code was written, and therefore they need to be refixed too. So you really have cascading failures that lead to a significant amount of rework when you find problems with this approach. So the approach of continuous delivery is really automating the process of building, testing, and being able to deploy code such that it is easy to do without manual intervention every time there's a change. So when we deliver code in this fashion, you're never looking back more than one commit in order to understand where there's a problem if you fail. You're not depending upon individuals. You're not queuing up for someone's time in order to do QA. That is being done as part of the development process. And you get to a point where you don't necessarily release every code change, but you could release every code change if you so choose to, because you have enough confidence in the software in order to be able to do this. And security, again, even as we started to adopt continuous delivery in a lot of organizations, we would see that security was actually continued to be treated in the old way. People would accumulate a lot of change, and then at some point they would ask for security to come in and do a review. At that point, you have the exact same problem. Either there was an old change, and when I talk about code, I'm talking about both infrastructure code as well as application code. There's a change a while ago. People have to go remember why they wrote it the way they did and fix it, and you have the same cascading problem when you do this. So the idea of continuous security is simply embedding the security validation process in the continuous delivery pipeline, fully automating it. As Chris was talking about, everything is code, both the security tests as well as the application as well as the infrastructure. And when we do this, we have essentially embedded completely the security review process such that as we make changes, there's immediate feedback whether there needs to be a fix from a security point of view, and we are comfortable with the release of that product from a security perspective each time we make change and the tests are passed. So I'm going to go pretty quickly through this. In order to achieve this, we need two key things. We need security of the pipeline, the continuous delivery pipeline we're talking about, and security in the pipeline, actually building this testing into the pipeline. Security of the pipeline, I'm not going to go into any real detail on, other than to point out the fact that if you're building your infrastructure through your continuous delivery pipeline, then your continuous delivery pipeline itself has the ability to change your security posture. It's a very powerful capability, but it's also something that you really have to pay a lot of serious attention to. So you really have to consider things like the fact that you're starting with code, your infrastructure is code, therefore people that can commit code can change your security posture. So you really have to think long and hard about what people can do, who can actually make code commits that are infrastructure code. You need to think seriously about how you lock down the pipeline itself, depending upon whether you're using a managed service like Code Pipeline or a product like Jenkins. There's varying amounts of hardening you really need to do in order to protect your organization from security problems in the pipeline. So I'm not going to go into any detail on that. Security in the pipeline is what we've been talking a lot about, and that is actually building that testing in the pipeline that validates your security. And the pipeline that I'm talking about is typically multiple stages. One of the key components or the key aspects of this is to get very rapid feedback, inform the developers of, give them security awareness, let them know when there's a problem. So the commit stage of the pipeline deals with examining the code. The acceptance stage with examining the application and any infrastructure needed to run that application. The capacity stage, examining an environment, a prod-like environment, going really deep on understanding the aspect of it. And then pre-prod and production are simply the process of creating a production environment and rolling it into production with the ability to roll back. So in the commit stage, we're talking about getting really rapid feedback for our developers. They make a commit on a CloudFormation template. They should be able to pick up a cup of coffee, take a drink or two, put it down, and have immediate feedback. Not only is it syntactically correct, but does it adhere to the security best practices? And this was our goal and objective on this project. So now, when I talk about doing code analysis of infrastructure code, of CloudFormation, for instance, this can't, we can't stop here, and we didn't stop here on this project. But it's a very valuable approach, because one of the things that it does is, and Chris alluded to this, is it actually allows us to stop bad things, security degradations of our environment before they happen by analyzing the code and then telling the developer immediately right away, hey, this is never going to see the light of day, and here are the reasons why. Go back and fix it, and then we'll let the pipeline continue on. So in order to do this, there really wasn't any tools that we found that gave us the ability to do static analysis of infrastructure code. So we wrote an open source tool called CFN-NAG. And it's a pretty simple and straightforward tool. It gives you the ability to scan CloudFormation templates, again, before you do a create stack, and find different kinds of what we consider obvious problems. IAM wildcards, security groups, wide open to the world, encryption being either turned off or let into default to off. So there's a number of different ways that CFN-NAG will help to validate your templates before they actually impact your security posture. But this wasn't enough. And in case of Verizon, we needed to consider different data classifications. We needed to consider different environments. We needed to be able to create rules for them and actually give them the ability to create their own rules that really met their organization's requirement. And this would probably be true with any enterprise. What we did is created the ability to be able to build custom rules. And a rule is really a very simple thing in CFN-NAG. You've got an identifier for that rule. That identifier allows us to group the rules into different profiles, and those profiles allow us to support different data classifications, different environments, different applications. You need a description. Description, it sounds very straightforward, but it's a very valuable piece of information, because that's what's used to inform the developer and make them more security aware. An indicator on whether it's a failure or a warning, and that's important because that is what controls the pipeline. It tells us, shut the pipeline down, go red, do not let this thing, do a create stack, and do not let this degrade my security posture. And then, of course, it requires some kind of logic. That logic is really a very simple process. It is, select all the resources of a particular type that you're writing this rule for, iterate through that list of resources, see if you have a violation, and then report the resources. And right here is an example of a very simple rule. Here, what we're looking for is wildcards being used in IAM policies. So as you can see, what I mentioned before, we've got a definite text of what the violation represents, the type of the violation. We have a rule ID so that we can group it into different profiles, And then we have a little bit of logic. The logic is very simple, as I just went through before. Find the resource that's under interrogation, iterate through that list, figure out if it's a violation, and then report it back. If we find no objects that represent a violation, then our template is passed. If this is defined as a warning, we will still pass. We will exit with a zero exit code, meaning that hey, the pipeline is still green, but the developer still gets feedback. And of course, if it's considered a failing violation, then we exit non-zero, and the developer is informed that the pipeline has gone red and they need to make a fix before they can continue. So what I'm going to do now, that was a very simple rule, and I wanted to actually walk through the development of a rule real time with you, but that was 20 lines of code. It would be kind of boring to do that. So we're going to create a new rule right now. But what we're going to do is we're going to use test-driven design to create this rule. So the first thing is, and in the notes that you'll all be provided, there's actually access to a number of different repositories that will help you. The first thing that we're going to do is create an empty Git repository. And then we're going to go out. We've created a prototype rule repository. We're going to grab that right here, pull it down, and this will kind of give us a kickstart in terms of writing this rule. So we're not going to clone this because we're not going to commit back to it, but we're just going to grab the zip, pull it down, pull those files out, and make those files essentially the core, the starting point to our application. So we'll move them into our repository, delete some stuff that we don't need, and then we will go ahead and we'll take a look at the gem file here. Just to let you know, some of the things that we're using here, obviously CFNAG is being used, but we're also using RSpec. RSpec is a language for writing test cases, and SimpleCov is a gem that allows us to analyze test coverage when we write code. So now there's a template that we can use to start to define our test case. And in this case, we're creating an RDS instance. And the purpose of this rule is to make sure that we're using encrypted storage whenever we create an RDS instance. So as you can see with this particular rule here, we haven't specified whether or not the RDS instance, the data is going to be encrypted. And the default is actually to not encrypt, and so you either, if you default or if you specify false for encryption, you will end up with a non-encrypted data. And if you specify that encryption should be on, true, then you will get a rule that specifies that you will get an encrypted DB instance. So the first and the simple test case was what I just described. We're allowing it to default, but we also need to test other test cases. Again, the idea is that we'll create all the test cases necessary to cover all the scenarios that we might run into. And so what we're doing here now is we're actually creating multiple templates to use for multiple tests that we're going to be developing in order to fully test our code. Now, so we've created true, false, and default, but people who work a lot with CloudFormation will also find out that many times, even though a parameter is specified as a Boolean, it will accept a string of true or a string of false as an equivalent to that. So we have two more test cases we need to do, and that's a string of true and a string of false. Those 5 test cases should be enough for us to validate the functionality of the rule that we're writing. So, and again, this pattern that we're going through here right now is a pretty typical approach to doing test-driven design. And that is, you come up with your test cases first, you come up with essentially, empty logic for your function or your class, and then you start iterating on it. You run it, you expect to see a failure because you're not doing anything. And then you step by step, you continue to add in the functionality to your in this case, rule, until it actually passes all the tests. And that's the process that we're going to go through right here in just a second. Okay, so now we're actually going to write the framework for our rule. Pretty simple. We require a couple of things: CFNAG violation and CFNAG custom rules. And now the class, if you remember, the rule is composed of an identifier, a text string, a indication of whether the violation's a failure or a warning, and then the actual logic itself. The actual logic itself belongs in a function audit impl. The whole class derives from base rule, and here we are filling out the text and the violation, the rule type, and the rule ID. In this case, we want this rule, I mean, as Chris mentioned, everything must be encrypted. So, this is going to be a failing violation, meaning that in the context of a pipeline, the pipeline is going to fail if we find a matching resource that does not have encryption on. We're using just a large number here for the rule ID. We provide CFNAG with a bunch of rules that come embedded with it, and so just using a large number will get you, out of the space that's normally defined by or normally provided by us. Okay, so now what we're doing is we're actually writing our test case here. Again, we're using RSpec to do this, including spec helper, and we also need to utilize the CFN model. CFN model actually is what takes a YAML file and turns it into a model that we can then interrogate with CFNAG. And I'm not sure if any of you have worked with RSpec before. RSpec is essentially a very English-like language that allows you to define test cases and what your expectations of the results should be. It's like I said, it's a very English-like language. One of the values of that is your test cases actually represent documentation of the expected behavior of the code that you're writing. So as you can see, very natural when the DB instance has unspecified storage encrypted. That's a failure. And therefore, we would return the logical ID. And so what we're doing now is filling out kind of the rest of the framework, the logic that's going to go in it. And essentially, we're going to load a template, and then we're going to instantiate the rule, and then we're going to execute audit impl in order to validate whether that exists. We're going to grab some code here from the CFNAG repository just to cut down on the typing. And you can see the CFN parser is what will actually load a template and give us the object model that we need to interrogate. And here we're instantiating and executing audit impl in order to find out if we get any resources back that are in violation. And then finally, indicating what we expect from the test. And in this particular case, we are looking at the template where there is no specification, and therefore we would expect to get back a result. We would expect to get back a resource ID that fails. So if we don't get something back, essentially what that means is that our code is not correct. And considering the fact that we have no definition yet in audit info, we expect to fail. And that's the process that you typically go through. You start with a failure, you start with no logic, and then you start building the logic until it passes the tests that define the expected behavior. So as we mentioned before, the basic logic is very simple and straightforward. Go through the object model, the CFN template, pull out all of the matching resources that you're interrogating, iterate through that list of resources, and determine which, if any, are failing, and return the resource IDs if anything does not match the criteria that you had. Okay, so we have what looks like the appropriate implementation of our rule. We're looking for nil or false, and either of those should return for us a resource ID, which means that we have failed. And now if we go back and run the test, you'll see that we've actually had a success. The template that we expected to return a resource ID did return a resource ID, and meaning that when you allow encryption to default, you will get back a failure message. But in fact, what we've done here is we probably jumped the gun a little bit. Again, when you're thinking about test-driven design, what you want to do is, you want to approach each use case individually. And we jumped the gun by saying nil or false. That's two different test cases. So what we did is we went back and changed it, make sure we don't get false positives, go through, check again, and validate it. And then as we work on the next test case, and start looking for specifically false, then we go back and add that logic. So here we're fleshing out the second test case separately of false. And now let's go ahead and do true. Or now let's go ahead and do true. And here we're adding false string, adding the two string cases that we came up with. And essentially what we're doing is building full test coverage on the code that we've written. Okay, so we have our 5 test cases now. And we run through 5 test cases, 5 passes. So, okay, so we think we have, through test-driven design, written a good rule. We're going to go and actually look at the test coverage. Again, good development practices. Go ahead and validate that not only have you written the rule and written tests for it, but that the tests sufficiently cover the cover the code, and you have high confidence that you've written quality code. And as you can see, we got 77%, which you would think is not a really good test coverage number. But then when we look at it, the areas where we don't have test coverage are, defining the rule text, the rule type, and we're really not worried about that. So we have a good rule, good test coverage, and just as the final sanity check, we'll go ahead to the command line and execute CFN-NAG and validate that it processes this. That it processes commands correctly or templates correctly. And so we'll first do a failure. And we get what we expect. We see that the template does not pass inspection, and then we'll do a true, and make sure that we do pass, as we have here, when we are encrypting our storage. Okay. So essentially what we've done, by developing these, the rules, CFN-NAG, using that to validate our templates, is we've achieved the scale that Chris was talking about needing. If you remember earlier, I was talking about the fact that we needed to have security resources in the development teams in order to achieve the speed and the confidence that we wanted. Well, we've done that, but not by putting people in those teams, because that's a solution that doesn't scale, but by automating the security analysis and giving the developers, giving those teams access to those tools so that every time they make a change, they will be able to self-validate on security. So that kind of solves half of the problem. But an organization like Verizon, very concerned about security, they still have a security organization that has to have a high confidence that anything that is getting deployed is in fact secure. So the question becomes, how do they get that high level of confidence? How do they get that trust? And this is really at the core of the project that we did. We need to be able to certify results. And the way we do that is, there's a few things that we need in order to be able to certify a result. We need to know what the object was that was under test, the CloudFormation template. We need to know what the test specification was, the set of rules associated with it. And we need trust in the administrator, whatever it was that carried out that test, that indeed the results that are being presented to us are valid. So, concretely, that means the CloudFormation template, the list of rules or the profile that I talked about earlier, the results, the actual text coming back from CFN-NAG, and then some mechanism of making sure that you can trust that result that you get. Now, the way that we achieve that is, CFN-NAG is presented to the development teams as a service. Being presented as a service means that we're encapsulating the service itself, CFN-NAG, and the rule set, and by packaging as a service, we're also able to give it a private key of a public-private key pair to sign the results that we were just identified, and therefore, at a later point, you have a document, an object that can be interrogated, and you will have a high confidence of what was tested, when it was tested, and what the results were. And this is an example of what that would look like. You would have a signature associated with it. You would have a template which is represented as base 64, and you would have the results of CFN-NAG. This is all wrapped in a signature, and what we're able to do is, in terms of consuming the test certification, what you need is some kind of you do need a gate function. That gate function exists prior to deployment. That gate function utilizes the public key of the key pair, in order to verify that this result, this this object came from the actual certifier, the CFN NAG service itself. So by doing this, what we have done for the source code so far is solve the problem of scale, of giving security capabilities to each development team without blocking, waiting for reviews, and given ourselves the confidence that the results indeed are valid, have run through the tests we have, and represent what our security posture needs to be. But we don't just do this for the commit stage. There are other stages. We don't have time to go into them in detail, but the acceptance stage I mentioned is a stage where we actually look at the application and the infrastructure that surrounds that application in order to validate it. And here we might use something like config and config rules in order to, once you create some resources through a CloudFormation template, interrogate your account and see if there's a degradation, a resultant degradation in the security of your account. And again, we go through the exact same process here. We wrap config as a service. We then sign it, and the gate process, the deployment process, is able to validate that it's gone through the second stage of testing. For the third stage, for the capacity stage, what we're looking at here is really going deep dive. This is not just looking at the application and its infrastructure, but it's actually looking at a prod-like environment, so that you've got the context around the application in order to validate that you will not suffer any security degradations. And the kinds of things you might do here, typically you're going to be doing, for instance, performance testing, load testing in this stage of a pipeline. In our case, we're also adding things like automated penetration testing using something like Z-Attack Proxy, or image testing, vulnerability testing using something like OpenSCAP, or a number of tools. And when I mention specific tools in any of these places, the tool isn't important. What is important is the functionality it represents. As long as there's an API associated with it, that serves. And there's a lot of good COTS products out there and SaaS products that will give you the same capability in order to validate security, and can be built into a pipeline as we've done here. So, in terms of bringing it together, essentially what we did is we wrote a tool for Verizon called or I should say with Verizon, because they had, it was one team working together. We created the infrastructure certification pipeline, and the idea is to represent security validation as services as opposed to manual reviews, to bring those together and expose them via an API so that they can be consumed by developers, and create it in such a way, the services, that we are able to validate and have high confidence in the integrity of the test results that we get back. And essentially then the deployment gate is where we validate that and are able to make a yes/no decision in a completely automated way about whether something can be moved to production or not. So, in conclusion, we've talked a lot about CloudFormation and templates. Today your infrastructure is code, and if it's code, you really need to treat it like that. So, and this is what we've been talking about. Go through the exact same process that you go through with application code for infrastructure code. Use test-driven design. Go through a continuous delivery pipeline. Analyze that code, and move it through the same process. Get that fast feedback that informs developers, gives them security awareness. Another key aspect is that infrastructure is part of the solution now. It's code. We should be writing it together as we're developing applications. It shouldn't be two separate organizations, two separate teams. A single team needs to work on both the application and the infrastructure necessary to support it. And when you start doing this, you'll find two things. From within a development team, utilizing continuous delivery and continuous security pulled into the process, it's going to give you reduced cycle time, and it's going to improve your confidence in the quality of the application and infrastructure that you're creating. But from the outside, from the security team side, what you're seeing is that it is also giving you a way to inject best practices as automated gates in the delivery process, allowing a security organization to scale and to meet the challenges of, as Verizon is doing right now, moving thousands of applications to the cloud and having high confidence in the security of the applications. And it really results in being able to have, being able to scale and have high confidence in security without grinding to a halt. So there's a web page, pretty easy to remember, stelligent.com/dev403. On that page, you will find the code examples that we went through here, pointers to the repository, pointers to a couple of articles on continuous delivery and continuous security. I would also encourage you, if you decide to start going down the process of creating some rules, please reach out to us on GitHub. If you think you've written a rule that belongs in our base set of rules, give us a pull request. We'd be happy to look at it. If you have questions of our developers, feel free to contact us through that means. And we can. This is open source. It's a community tool, and we'd like to engage the community to help us advance it. So, at this point, I've only got about 3 minutes. Quick questions for myself, Matt, or yes.
Can you describe what this journey has been like when you started? Are you still developing and implementing a lot, or have you stabilized? Relatively, how long has this all taken?
Okay. So, Chris, we started approximately, 10, 11 months ago? Right around beginning of January? When did you come up here and talk a little bit?
To build the pipeline as Chuck described, it took maybe 4 months, 5 months, and then it becomes more run rate. But it's really, run rate means constant development, right? I think it was just this week that AWS announced DynamoDB supports server-side encryption. So right off the bat, it's like, hey guys, when can we have a CFN-NAG rule to enforce server-side encryption for Dynamo? Anytime we want to evaluate new services to introduce them to our organization and enable a new service, we want to CFN-NAG rules. If there are any policies or any security implications to whatever the service is, we want to automate the checks. It's important to know too that this is a gating factor for production. It's not for sandboxes, it's not for the lower level environments, right? So we're not going to enforce it necessarily there unless it's consumed independently via the APIs. Its developers can run it against their CloudFormation anytime they want. But to get to production, it has to pass and it has to be certified. So I would say 4 months maybe, and then tweaked, and there was some knowledge exchange that was involved. Maybe we'll say 5 months from beginning to end. And then it becomes run rate, and that run rate means it's constant expansion. And we didn't get into a lot of the AWS config stuff, but once CFN-NAG certifies and your static analysis is complete and it passes, we then temporarily provision that. We run the CloudFormation, we provision all those instances, and then we hit that up against AWS config rules to make sure that nothing has changed. So the posture hasn't changed. We still have all the policies that we want in place. And again, another certification, right? So it passes. And then the last phase, and I know you touched upon it, is then we just make a call to an agentless vulnerability scanner, and we scan the boxes, whatever we provisioned, and it has to be vulnerability free. And those are the 3 certifications that get dumped into Artifactory, where it's a secure location, and when we execute via one Jenkins and do our actual prod deploys, it goes against Artifactory. It doesn't necessarily go against where the repository, where your CloudFormation is. And we just do a CloudFormation version check and a certification check with the keys, and only certified clean code is deployed into production. And the proof is in the pudding, right? So everything that we've been deploying into production, typically vulnerability free. We haven't seen any issues with it. But keep in mind, and I would highly recommend you take a defense in-depth approach, right? So this is a great program, but you still have administrators that could create something, and you still need to be monitoring for it. And I would argue you need to auto-remediate too. So we're not seeing any issues in our production environments, especially our LOB accounts, but I'm not going to rely 100% on this. I'll rely 95% on it. But we still have the other things going in the background, just monitoring the environment, making sure that nobody does something crazy like an administrator or something like that. But it's a very, very effective tool, and it scales. Once it's up and running, it's just maintenance mode. Build signatures and test them, right? So when you build a new signature, you got to test it and then deploy.
And by the way, after the 4 to 5 months, Chris's team was completely able to run with it on their own. They're completely self-sufficient. They're not actually coming back to us asking for more assistance on that aspect. We're still working together, but on other things. Really his team is off and running. They're writing their own rules. They're making their own modifications. Completely self-sufficient.
Yeah, and just to add, so in CFNAG, we got about 150 rules we check. Every time it runs, it checks 150 things. Depending, if you don't do RDS, it's not going to check that, but fully baked, if you leverage all the services via your CloudFormation templates, it would do 150 different security checks.
There's a question in the back. Go ahead.
Yes.
Who would a trusted test administrator be in practice? So, and how would they have certain skills or training or anything like that?
Oh, okay. So when we talk about the trusted test administrator, that is really a security service. It's an automated function. It's not a person. Right. And the way that you get that trust in it is, as I was describing, utilizing public key encryption. You have a private and a public key. The private key is owned by the service. It's encapsulated within the service. Therefore, any result that is written by that service can be verified by, further down the pipeline, a deployment gate as, the proper source of truth for the results.
Right. Okay. Thank you.
Sure.
Question over here?
Yes.
Go ahead.
So you obviously so you're going into the cloud as the first time for applications that are suddenly encrypted or things like that. How do you deal with applications that might have some security posture that later on you come in with a new rule and now they're violating the rule? Do you hold them back and say, you got to fix everything before going to production? And how much pushback do you get with that? How does that all work?
Yeah, so for those who didn't hear the question, it was once we've certified and deployed some infrastructure and it's passed all the rules, what happens if the rule changes? What happens if there's a new risk or a new service or something changes and what you've certified already is no longer really ready for production? So there's a couple of things. So number one, we have rehydration, right? So everything has to be rehydrated, rescanned, redeployed, and that's at a certain frequency. But in essence, what we also do is we manage and monitor Artifactory. So if something changes, we just go and remove the certification so it can't be deployed again. So if something were to change tomorrow and we had certified CloudFormation templates, we just go in and remove the certification. You have to just rerun it again. After we update the rules. Yeah. Yeah, well, fortunately, it doesn't really happen that often, but it can happen. And typically, rehydration takes care of that because the developers are rehydrating and redeploying all the time. And when they do that, they have to certify to redeploy. Think about it in terms of automation. So Jenkins is deploying everything. Jenkins will not deploy it unless it's certified. So there's really no choice. The developers have to go through this process to get code deployed. And then what we do is we just control the rules. But to your point, we can go back and remove certifications. There's many methods in which we enforce it. And if something were to change, we certainly will pick it up with new deployments via rehydration. But we can also go back and remediate if we have to.
Yeah, obviously, it's one of the situations where security probably takes precedence over, the drive to get something out. I mean, it's not a good situation. Like Chris says, it doesn't happen that often, but you can't risk your security posture.
Yeah, and the other thing to do, you got to remember, risk-based approach, right? Depends what it is. If it's something we can live with for the next 25 days till we rehydrate this application, then we live with it. It depends what that risk is. Typically, you're not going to see a change that's going to go from no risk to very high risk with an existing service, typically. But it can happen, and we would have to address it at that time, depending on what the risk is.
There's a question here in front.
Is there another question?
Sure.
Yeah.
Sure. Right. Right. So if I understand your question, you're asking why wait to prod to have to do this type of a scan? Right. Yeah, definitely you want parity between non-prod and prod. So it's a gating factor, right? So this is a gating factor to get to prod. It's not necessarily the only place that these rules are used. The developers call, there's APIs for CFNAG. They could run it against their CloudFormation templates anytime. And we encourage them to do it, but we don't force them. So we're not trying to force it on the developers. If they want to wait to the very end and see it for the first time, that's their issue. It's available to be consumed in any environment at any time. But we use it for as a gating factor, and the gating factor is at that point in prod.
So would you not recommend pre-preparing?
Oh yeah. Yeah, we recommend it and we help people use it and do exactly that. Yeah, absolutely.
Yeah, but what Chris and his team are trying to do is at the same time, guaranteeing the security. They're enabling these teams, to have their autonomy. So, yes, we absolutely recommend that, every time you make a code commit, you're running these tests, and that's why we're exposing it as an API, all of the security services. But what we don't want to get into is an environment where they are dictating this is what your development process must be. Anyone else?
Any other questions?
All right. Thank you, everyone.
Thank you all.
Thanks, everyone.
All right.